Hello everyone. Thank you very much for being here with me today. Today we are going to speak about SAST tools and share some things about my experience using them with development teams. And we're going to talk about the most common findings and mitigations and how to gain value from using SAST tools. So I am Stella Varvarigou and I work for Code for Thought as a software engineering consultant. And actually we work with development teams in order to give insights and consults in order for them to write more maintainable code and more secure code. And I have also worked myself as a developer in large-scale systems. So let me show you the big picture in the first place about application security. A GitHub report shows that no matter how much money has been invested in application security, still 85% of the applications contain known security vulnerabilities. And in fact, these vulnerabilities are not fixed prior to 6 months mostly. So something must be done the wrong way. So let's see how we can approach security, application security, in a way that we produce more secure software. So let's take a look at OWASP Security Assurance Maturity Model shows on how to approach application security within an organization and how to produce secure software. Actually, it mentions 5 business functions in order to help the production of software, and these are related to governance within the organization, trainings and strategies regarding security, and then system design and security requirements, and then implementation, how secure is your build, for example, then verification, which is related to testing, and for example, do you use enough tools in order to test for security, and then operations, for example, what happens when an incident occurs? Is there a team responsible for handling this? So we are going to focus here on secure build because it's closer to developers, and we're going to see how SAST tools help to this direction, secure coding. So there are many types of tools someone can use during the software development lifecycle. For example, in the design phase, you may use a methodology called secure threat modeling, for example, in order to identify the basic threats your system faces. Or you can use dynamic application security testing in the testing phase and penetration testing. And we're going to focus on static application security testing, which concerns the develop and build phase. But what actually are SAST tools? SAST tools analyze your code, your source code, even compiled versions, in order to identify security flaws. And this is called white box testing, and they can be integrated in your IDEs or your CI/CD pipelines. But what is not static application security testing is, for example, software composition analysis, which identifies the third-party code, which may contain security vulnerabilities. So what are the most critical findings SAST tools discover? They can discover, for example, hard-coded credentials, or they can discover code injections. For example, a user's input may provoke the deletion of a row in the database or the modification of data. They also discover weak encryption, the usage of deprecated algorithms, or they may discover sensitive data leakage. For example, The number of a credit card may be printed in a log or something like this. Then they discover input validation and log forging. For example, someone's input may be used in a way to create a false log. So this will cause a problem then in the auditing phase when a security incident occurs. But what makes these categories the most critical? Again, OWASP has identified the 10 most critical risks on web applications. And which are they? Let's take a look. For example, these are findings related to broken access control. For example, does the user have access to the data and functionalities that they should have? Or the next one is cryptographic failures. The next one is code injection. And then insecure design. The next one is security misconfiguration. For example, do the frameworks that you use have secure defaults? Or they have broken windows, for example. Then it is important to check for third-party vulnerable components, like third-party libraries, dependencies. Then an important category is authentication. Is your authentication mechanism, for example, centralized? Then software and data integrity failures. Then do you have enough logging to cover security critical functionality? For example, when a user logs in, do you log the success, both the success and the failure of the event for auditing reasons? And last but not least, server-side request forgery. For example, when your application fetches a remote resource, is the URL valid or is it malicious? So there are also other models who prioritize such category of findings, and these are prioritized based on how often they occur, how often do we have cryptographic failures in applications. It's more like a statistic. So other models as SIG Security model do a similar grouping of critical findings. And then, for example, another one is the top 25 of common weakness enumeration. But do they actually have impact? Let's see a real incident. Toyota had been developing a mobile application, and a subcontractor had published part of the source code in a public Git repo, and this contained an API key which provided access to customer data. And this was public for 5 years. So, actually, yes. So a third party could use this API key in order to have access to customer data. It could be a very easy way to take advantage of customer emails and perform phishing attacks impersonating Toyota. So SAST tools could prevent this. And this is an example of an output of a typical SAST tool. There is the identification of the finding in the highlighted line. Here we have a deprecated algorithm, SHA-1. And most of the tools also provide the category where the finding belongs. For example, this responds to cryptographic failures on OWASP top 10 list. What is more, information could be given about the CWE identity. Here you can see its use of broken or risky cryptographic algorithms. So this kind of information can also be provided by SAST tools. Let's see some findings and some common mitigations. First of all, hard-coded credentials, which may be weird, but we see it very often in the code bases that they are not handled. as much as they should be. So, first of all, someone could use tools to encrypt application credentials. For example, an example is JASIPT tool for Spring Framework, which encrypts application properties values. Then someone could store credentials in environmental variables. And last but not least, GitOps and CI/CD tools provide you solutions in order to store and manage your secrets. In the case of the cryptographic failure, this could be the solution, the usage of a more strong encryption algorithm with the usage also of securely random salts. Then here we have an SQL injection example where a query is formed with user input without it being sanitized. And this could end up to malicious actions to the database. So a good solution would be to use parameterized queries and sanitize always user input. This may sound trivial, but these are the core cases that could make an impact to your everyday work. So let's see, apart from that, the benefits of SAST tools, of using SAST tools. First of all, literature shows that the earliest you discover bugs as well as security flaws, the less it costs, both in terms of resources, time, and money, of course. And it seems that in the implementation phase where we use SAST tools, it costs, for example, six times to fix a bug, whereas this in production multiplies. So the next one is that SAST tools provide you continuous feedback. When you write code, you immediately get the feedback on how secure it is. And it is important because it is easier to make fixes, there's the time, and there's no stress. And in the opposite side, when a vulnerability is found in testing or deployment phase, then maybe you could end up in a situation like this, especially when a vulnerability is of high severity and impact. And what we also observe is that some development teams adopt SAST tools later in the timeline of the development, and they end up finding security vulnerabilities related to past implementations, and then extra pressure is created in order to fix them, and most of the time pressure from the management. So this is what we want for sure, the early adoption of the SAST tools, which could have actually an impact, and this is what we want to avoid. Then SAST tools provide you visibility on the security flaws of your whole code base, and it is important to have this, to be aware of your code security. But apart from benefits, SAST tools comes also with challenges, and I think we should have some share on this matter. It is a fact that SAST tools generate a large number of false positives. For example, in the first place, you perform the static analysis with a tool you choose, and it provides you a list of security findings, which is unfiltered yet. Then someone has to do the filtering, the assessment, if the findings are true positives or if they're not. And this takes time, actually. Someone has to do this task, for sure. But the good part is that you get familiar both with the findings and the process, and it's a process that can be improved and take less time the more you work with SAST tools. In addition, SAST tools require experience and knowledge because the types of findings are really numerous, and here are just a few of the findings that are produced, the categories that are produced by the SAST tool we use. So maybe a training is needed and some expertise is needed, but I would mention again that familiarizing with SAST tools makes it always easier. Then SAST tools produce a large number of false positives. OWASP benchmark project mentions that only 20% of the findings are actually findings, and to our experience, this is very close to reality. And assessing the findings also depends on the context of the system. What is more, SAST tools miss things. For example, they cannot identify design problems, or they cannot identify business logic issues, but this can be handled with other methods like manual code reviews or threat modeling. So what is the best way to work with SAST tools in order to get some value out of them? First of all, prioritize. Based on the most critical findings, I would suggest to focus on them. After all, your system security is equals to the criticality of your most severe vulnerability. So prioritize and begin with the most critical. Then set achievable goals for your teams. And what I mean is that, for example, you may decide that in every sprint, if you work agile, you may choose to fix 2 security findings, or you may create a security sprint in between in order to focus solely on security. Last but not least, you can combine SAST tools with other tools in order, again, to prioritize and handle your workload. And what I mean is that, for example, if you perform threat modeling and you find out that sanitizing user input is very important because you have a public-facing application, then you can focus on a whole class of findings, for example, SQL injections or cross-site scripting, and then prioritize to eliminate this whole class. What we do, and this is a practical approach, you may find your own way to use the tool anywhere in any step of the development work you do. But what we do is that we get client uploads, and then an automatic process runs, and SAST tools analysis runs, and it creates a list of findings, and then we do the filtering as consultants. And then we communicate the findings to the teams through an online platform, and we discuss with them most of the time if the findings are actual risks for them. For example, sometimes security team may give some input, and we discussed a lot, and then a list of selected findings is produced by this process, and the findings are prioritized to be solved. But let's see now what are the next big things on SAST tools, because these are tools that are evolving along with what is happening around at this period of time. AI is already influencing static analysis. For example, GitHub Copilot, we all know that it has increased developers' productivity, and it has also improved code quality produced. But on top of this, GitHub Copilot goes to a secure coding direction with identifying patterns of insecure coding, such as hard-coded credentials and SQL injections. Someone may say that these tools are as smart as their training models, and for sure this is just the beginning, but the important thing is that tools are going to this direction, to secure coding. Another one is CodeQL, a tool by GitHub again, that performs semantic code analysis, which means that you may query your code as data, and you actually give a description of a starting point and an ending point, a sink and a source, as they say, and in between you describe what you're looking for. So they claim that in this way, false positive findings are dramatically reduced. Last but not least, there is SEMgrep, which is a tool that also identifies patterns regarding security vulnerabilities. You may describe again what you're looking for, and what's the most interesting part is the element of autofix. For example, when you identify the finding, you may replace it with something and fix it immediately. What matters is that we need to make a cultural shift towards security, and for sure this starts with developers, and SAST tools is an important tool on your hands, so I think that they give you value for sure. So that was about it. If you have any questions, I would be glad to answer.
You mentioned before that regarding the issue that the SAST tools have, which means that they have an overhead in your development lifecycle, that you need to spend time to filter, blah, blah, blah. Do you have any best practices to recommend, or any flow or whatever, so that this can be speed up or not be an impediment, for example, for the delivery of the project?
Yeah, that's a very good question. In my experience, using SAST tools, what happens is that the more familiar you get, the faster you do the job. And of course, you can use them by prioritizing findings. For example, you may say that I will look only into the critical or the high severity findings. So this is kind of a handling of the situation. And I think that also, tools are improving, so it would get easier to use them and be more efficient with them.
You mentioned that you can't find any secure design through SAST.
Security, sorry?
The insecure design of the system through SAST. How would you approach it to
Insecure design.
find the documentation to know how to find centralized design?
Okay, you could do a research on threat modeling techniques. There are frameworks like Stride, for example, which focuses on areas like spoofing, tampering, and other areas of design, of the system design. So you can approach the design this way by frameworks. And I think mostly this way. Or you can perform manual code reviews, and you can, for example, you can look for specific documentation on the framework you work with, and see how things like authentication can be centralized through a framework.
Many companies and organizations have very strict rules about external tools.
Yes, that's true.
How security consultants can convince them to accept these tools because there are regulations.
Yes, that's true. I guess you are referring to, there's an issue that some companies do not allow their source code to be externally given, scanned. Okay. I think a good practice would be to actually show what values these tools give for the developers. I know that management is really difficult to persuade in such changes and decisions, but I think it's worth a try to actually show, sometimes also with numbers, or for example, a good example would be to report the number of findings from penetration testing, and then you could say that, for example, SQL injections could be discovered much earlier by SAST tools. No, there is argumentation like this, but I know it's difficult. Welcome.
Stella, very nice presentation. It was really, really nice and useful information.
Thank you.
In slide 22, we've seen that 80% of the outcome is false.
I know it's provocative.
Do you think that AI and machine learning can help the next few years to minimize these 80% into
Yes,
possible
I know.
zero?
Actually, a lot of work is being done, and I actually believe that AI can give value into this. And actually, what I said about CodeQL is that the best, it's if you define in a very specific way what you're looking for, you may be able to really minimize the number of false findings. But there are tools that are very customizable, and I think that a developer could experiment a little bit and see what he can do, or she. Mm-hmm. Yes.
What about the variety of tools? So a developer can work with two different
Mm-hmm.
tools. This add value to his or her work.
The different types of tools, you mean in the SDLC?
No, I mean scanning
Mm-hmm.
with some now, but two different scanning tools.
To different scanning tools. In my experience, I think that is superfluous. I mean, it's extra work, and I think that take a tool, use it, have the experience with it, and I think that most of them discover the same types of vulnerabilities. I think that I know it takes time and it requires time investment, but I think the best way to find something that actually gives value to you is to try it. Welcome. Yes.
As you said before, the static analysis tools don't look at business logic.
Mm-hmm.
Is it acceptable to use business checks instead of something else? For example,
Yes, of
injection?
for business logic, what comes to my mind is that you can design unit tests regarding security specific. So I think that these business kind of logic mistakes could be avoided by unit tests, by security unit tests. So this could be another methodology, another approach. I don't know if I answered the question. Maybe I didn't understand it well.
I was saying that you have some business checks,
Mm-hmm.
business rule checks.
Okay,
So
okay.
you won't check when a request comes,
Mm-hmm.
you won't check for the variables.
Mm-hmm.
You will check
The input, you mean?
You would
Of
say
course.
the input based on business rules.
Yes,
So
that.
the stock analysis won't.
Okay. Yes, in my experience, I understand that user input should be sanitized in order to avoid running a malicious script. But of course, business rules may not be, for example, security-oriented, but they are important for the functionality of your system. So yes, I think that they are related security-wise. Security, I mean, I actually think that security is a very broad field. So I think that it has many approaches. It's not like testing that you test for something specific. You try to cover the biggest parts of the threats. You can't always have it all. It's very difficult, and you actually don't know. You may not even can imagine the threats, but you have to do what's best, and what's the most you can do. There are principles that you can follow and hope for the best. Yes.
It's actually a follow-up to the question asked about sharing the code and allowing it to be scanned.
Yes.
And I was wondering if there's such a thing as scanning the SAST tool to prove that it's secure enough.
How secure are SAST tools? Well, that's a question. Yeah, a meta question. Yeah, that's a good question for food for thought. Yeah, but it's actually, SAST tools are actually a system themselves, so yeah, security should be taken into account.
In order to persuade the manager to accept testing them.
Yes. Yes.
As a follow-up again, the question because it's because it concerns us because I'm in a EU government organization, so sharing the data is really important. Is there the possibility of actually owning the SaaS tools in terms of having them installed and run in our own on-premise or in our own VPC or something?
Yes,
like
of course. Of course, they can be locally.
So the security consultants are okay to use the tools that are installed actually, the external security consultants, okay, are okay to use tools like that that are on-premise based on the company and not in their possession?
I want to ask this question a little bit in a way that is not in my favor as a consultant, but I think that developers can use these tools by themselves. I mean, tools like SEMGREP do not involve any consulting in the middle, so I think it's important to adopt the tools and actually get experience. And I mean, it's like testing. It's like when testing was firstly introduced. Every developer should learn how to write unit tests. I think it's the same analogy here. Any more questions? Okay, thank you very much.